Greetings. My name is Craig Strong, and today I'll be presenting how we instituted DevOps within a legacy-heavy criminal justice system and how the Kanban method served as our tour guide along the way. Now, whether you're using Agile methods today or not, my goal by the end of this presentation is for you to have a better idea where and how you could use the Kanban method to help you on your journey. So I've been in software development for a long time. I own a consulting company based in Times Square, New York City. And my company works with the federal government, New York City government, and commercial companies. You can see some of them here. Now these days, most of my work is in coaching and training, but I still keep my hands dirty and write software, write code from time to time. All right, so today, I'll first define what I mean by the word DevOps, and then give some background on the project and why we needed DevOps. We'll then go through how we implemented DevOps practices step by step on the project and what happened as a result. And finally, we should have a few minutes at the end for questions. So here is the official definition of the word. Of course, we're trying to bring development, operations, and QA closer together. But what does this imply? Well, it implies changes across 4 areas. There are new tools that we need to implement. We need to streamline our processes. We need to make them more lightweight and adaptable. Cultural change, now that's the most important. We've got to move away from the command and control concept to more collaboration and trust. And that means no more shooting the messenger. This is not Sparta. We have got to treat failures as an opportunity to improve our processes so that the failure becomes impossible. Now, last but not least, these changes will ultimately impact the entire organization, right? So, great. So how do we implement DevOps on our project? Well, we decided it would be a mistake to try to take on everything all at once. So we divided the work into 4 major waves: build automation, test automation, deployment automation, and configuration as code. So let me tell you about our project. So this is depicting the overall process where we start with, unfortunately, a crime that has been committed. We gather physical evidence, in this case blood, and from that we can extract DNA and digitize it using a process called electrophoresis. Now once the DNA is digitized and stored, we can try to match it against all the other profiles in our database, and that's where our software comes in. Now hopefully we find a match, which leads to an arrest and ultimately a conviction. So this software has been around for a long time. It started out as a spreadsheet in the early 90s. And then after the DNA Identification Act was passed, an initial implementation was done using VB6, late 90s. Now that grew, it got rewritten in .NET, and then a new architecture was created to enable us to really scale up to the millions of profiles we ended up with. Finally, about 8 or so years ago, we started working on rapid DNA technology. Now that basically shrinks the time for creating the digital DNA profile from days or weeks to just a few minutes. So ultimately, we ended up with a product with millions of lines of code, some new components, some old components, and a big challenge. So when the customer said that every time you fix one bug, you create 2 more, we knew we had to make a change. So why is Agile and DevOps so difficult to implement in legacy environments? Well, there's a number of reasons. First of all, the cost of failure is high for a system like this. Bad guys could get away. So because of this, naturally there are statutes, there are regulations that have to be followed, that kind of stuff. And of course, to go along with that, there's going to be a fair amount of oversight reporting. the space itself, the facility where we're working, may not be conducive to Agile, right? It might have been put together, 10, 15 years ago. So, and now we're probably all working remotely. So that's another difficulty there. So also, if you have a lot of staff that's been working on this for 10, 15 years, they may be rolling their eyes when you say, oh, we're going to go to Agile, and saying, oh God, not again. We've already been through this. We had total quality management. We had Six Sigma. We had all these different fads. They come, they go. Why should this be any different? So it may take some time to sort of break through that resistance to change or that battle fatigue and say, let's give this a chance. Let's see what happens here. See if we can make some changes, some positive changes. Then there may be a lot of documentation requirements. First of all, the documentation just may be missing, or there, especially with the federal government, there's just a lot of documentation requirements that you just have to fulfill. Testing, well, first of all, it's probably all manual, and the latest technology, the latest test automation tools may not even be supported. Now, finally. So, all this may be true, but at least, we can buy new things and we can get started using new tools. Well, not so fast. Actually, procurement can be very challenging, and there can be this lengthy approval process. You probably have a big battle to get these new tools in. So, so what about the Agile community? Can the Agile community help us? Well, yes and no. Unfortunately, there's surprisingly little guidance out there for brownfield projects. Most of the Agile books kind of assume that you're just starting from a clean slate, And then if you look at the Agile practices, you might wonder, well, wait a minute, how can I start up doing 2-week sprints if it takes me 8 weeks to test the entire system? How does that work? So, and finally, the tooling. As I mentioned, the automation tools are poorly supported. It's data heavy. There's just a lot of difficulties there. So at this point, you may be thinking to yourself, my God, that's it, I'm out of here. So why would anyone in their right mind, sign up for something like this? Well, there's some good reasons. First of all, there's the mission. We had, it's nothing like the feeling of, we're helping to save lives. And that's what this system is really all about. And it really helps me get out of the bed in the morning. So it's a big one. Second of all, just the sheer challenge. Can I do this? Can we get this done? Third, we had a great team. It was really fun working together. We had a great time. So some good reasons to actually go through this. So we knew that we needed to institute DevOps, and we decided to use Kanban to help us get there. Now, as a Scrum team, you might say, well, why, you're Scrum, why would you use Kanban? So let me explain. Well, first of all, what is the Kanban method? Now, a great way to get started is to use static, and that's what we did. So the systems thinking approach to implementing Kanban. And static, it involves these 8 steps here, and essentially what happens is it says, first you have to understand the system. You have to explore the problems so we really understand the issues and really dive deep and really understand the root causes for what's going on. And we analyze at a deep level our demand, the different demand on the system, where we're different, how we spend our time, and our capacity. What is our capacity? And then we model the workflow. Finally, when we include the classes of service, how we're treating things like first class packages and business class and all that stuff, expedite, fixed date. When we define these classes of service and we define our policies, put that all together, and we finally have our full Kanban system. Now at that point, and that's still a Scrum system, so we've just sort of used Kanban analysis to better to make improvements to our Scrum system and to help improve by implementing DevOps. So at that point, are we done? No, not at all. This is just a starting point, and from there we keep on iterating and improving. So let's take a look at what happened when we did a demand analysis on our system. Now what's interesting is we had already defined two different types of work. We had our business user stories and we had our technical user stories. And what was the difference? Well, business user story was really for a feature that came from the product owner, in our case. And the technical user stories came from the team, really the chief architect. These were sort of framework improvements, architectural improvements, improving performance, that kind of stuff. So we had these two kinds of user stories. Great, no problem. But what happened when we did a deeper analysis, put on our Kanban lens, and we said, let's see where we're really spending our time? What we found was pretty surprising. We found that, in fact, with this deep analysis, we found that we had to triage issues from the help desk. Sometimes we'd get level 3 help desk stuff. That was always expedited. Drop everything. It doesn't matter what you're doing. Drop it and get it done because bad guys are getting away, right? So super important. Of course, we had to support brand new labs. They brought on new domestic labs, new international labs, and there were certain changes to the database that had to get done, different scripts that had to be created to make that possible. And of course, those had a fixed date because that script has to be ready by the time the lab needs to come online, right? Or things get delayed. So those were pretty important. We had documentation, right? And we really wanted to capture those as separate things so we could really measure how much time are we spending on documentation versus these other kinds of user stories. Now, normally you'd say, well, just make it a user story. But in our case, we really wanted to segregate that out and understand how much time are we spending on software versus how much time we're spending on documentation. It turns out, spoiler alert, we actually were spending about 1/3 of our time on documentation. And frankly, the government said, you know what, that matches my expectations, that's completely fine. So they were fine with that. Interesting, right? So, but documentation wasn't the only thing. As soon as we submitted documentation to the government, any rework that was required had to be expedited. Like that had to be delivered immediately. So that was another thing. We'd drop everything, fix up the documentation, and resubmit it. So that was another one. Finally, we had technical chores, and that took up a significant amount of time. So what are we talking about with technical chores? Well, things like installing SQL Server, upgrading versions of Windows, installing older versions of Windows. And this is the kind of stuff that you have to do when you're supporting hundreds or thousands of end users all over the country, all over the world, many of which may be on older platforms. Right? So that's the kind of thing you have to do. So with all this in mind, here is an example of our task board, right? Our good old Scrum task board right here. So this is showing a user story on the left. We see all the tasks that are part of that user story here on the right. You can see they start out in new, go to active, then they're resolved, and finally they get closed after they're reviewed. This is great, good stuff. And the nice thing is that this allows us to capture every single piece of work that everybody needs to do, all collaborating together, to get this particular user story to be done. Right? Great. So this is good. Captures all of our work. We got everything there. So what's the problem? Well, what we found was that actually, in a given sprint, most of the user stories were finished right at the end. See that hockey stick there? So this means that in the beginning of the sprint, what are the testers doing? Well, they're basically kind of sitting around, right? And what are they doing at the end? Well, they're going crazy, and they're crazy busy. And quite naturally, many times we didn't finish the testing, and guess who got blamed? Of course, the testers. So was it really their fault? Yeah. So let's take a look at our Scrum workflow capturing it using a Kanban visualization, right? We saw the task board. Now the task board's fine. We're still using that for our daily scrums, but let's do a visualization of the overall workflow. Kanban is great for that. So that's an additional visualization, right? So, and here it is. So you can see what we've done here. We've got a picture of a typical Scrum workflow. And by that, what I'm talking about is on the left, the input queue, AKA product backlog, right? That's our product backlog. And you can see that, of course, we do some backlog refinement, right? We're talking about our story ideas and turning them into fully fleshed user stories, right? And once they are, then they're ready. They're still part of the product backlog, but now they're ready. And once they're ready, you can put them in the sprint backlog, and that's the next column, right? So once we're in the sprint, then we start working on the user stories. They're in progress. Then when development is done, they move to test. Then when they're finished testing, they're done. Then the product owner is the one that accepts them, and they go from done to accepted. So this is sort of showing you the whole life cycle, the Scrum life cycle of a user story. Whereas the task board was really showing us the tasks, inside of a user story. So if you will, this is sort of like one layer above. The task board was way down at the lowest level at the individual tasks. This is showing us up a little layer up above at the user stories and the flow of user stories. Right? So both are valid. In fact, I use both all the time. But this is a very interesting way to visualize. Now, in our case, we had a little bit of a longer sprint because we had to update lots of documentation every time we completed a new feature. So we ended up with more than 2-week sprints. But notice we had a bunch of problems. So look at all this red here. We had defects, rejected fixes, issues getting blocked, for various reasons. So what we really need to do was take a deeper dive and see exactly what was happening. Now we did that through a group retrospective, as well as individual team member interviews, and even an anonymous survey. We really wanted to get the unvarnished truth of what was really going on. So what did we find out? Well, here's a summary or a synopsis, some of the major things we found out. So first of all, of course, it really wasn't that surprising, honestly. Developers are checking in code that breaks the build. There's a lot of defects. It's brittle. The code is brittle. It takes a long time to learn the code, and it's very brittle. The tests are really difficult to write because there's no framework for the tests. So the developers have said, look, yeah, I could write a test, but if I did that, it would take 3 times longer. And do you really want me to spend all that much time? And the manual test environment, even creating that and getting that ready so the testers could test manually, that itself was very onerous, very, very difficult to prepare. And as you might expect, we also ended up with a lot of configuration problems, just configuring things and getting everything to work. A lot of issues there. So armed with this knowledge of all these specific issues that we needed to solve, now we went back and we said, okay, we thought we knew our workflow, but actually, let's see what's really going on here. So here's the workflow as, sort of the canonical Scrum workflow, right? Of the user stories as they go through. But what's really going on? So what we really found is that, first of all, there's a peer review. That's a good thing. So everything after development, before testing, had to go through peer review. And that was always happening. Our workflow, we just hadn't captured it properly. So now we've actually captured that, oh yeah, there is this peer review step. And that's important. We wanted to make sure we captured that. So, and then we noticed it took a long time for the build master to create a build. Well, naturally, it's a manual build. This just takes a long time. So what's happening to the user stories as we're getting that build together? They're piling up. They're stacking up. So all these user stories are stacking up, waiting for the build master to get ready to do a build. And as they're stacking up, we're having to do merges. We're having to do all this stuff. It's kind of a nightmare. So There's a lot of work there in the build ready queue. And that wasn't, it was always being done, but it really wasn't showing up in our previous workflow. So this one better illustrates what's actually happening. But that's not all. Our deployment takes a long time. So there's this step where things are kind of hung up there, waiting for deployment. And until that's done, the testers can't work. So you could even be ready to go, all the developers are done, but the testers can't get started because the new code is just not in their environment yet. So that was just taking a long time. So that's the deployment step. We had to capture that. And the environment itself, all that stuff. There's a lot of setup there. And then finally, packaging for deployment has another whole set of steps to do. So pressing a CD and all these different things that had to be done, many, many steps. So there's a lot going on here. There's a much more complex workflow. And this was always happening, but it had never been visualized. So imagine, as a manager, you're saying, guys, what's the holdup? What's going on here? And you're getting more and more frustrated, naturally, because this is what's really happening, but you're not seeing this. So imagine how frustrated you'd be as a manager to see this sort of very simple workflow and you think everything's just going fine, when in fact this is what's really happening. So this helped a lot just by visualizing, just by seeing what's going on. And the Kanban method gave us the tools to do this. Now, did we still have our task boards? Sure, naturally. Nothing wrong with the task boards. And they're still useful for divvying up work and seeing what everyone's working on. But this additional visualization really gave us another tool that was very, very helpful for seeing where's the overall flow of all the work. And especially at a managerial level and a coordination level, this was extremely helpful. Sometimes this is called a level 2 board, and the other board would be a level 1 board. So coordination level. So we need to fix this. How do we fix this? Well, step 1, let's get started. And the way we did it was build automation. Let's automate that build. So now normally, an automated build looks something like this. Your script forms a series of steps. You're compiling your code, you're running whatever unit tests, very simple, small little tests, package up, publish everything, you're good. Maybe you have a couple different lines going in parallel for the different branches. And that way developers, even when they're in their own branch, they can get the feedback. This is great, this is great stuff. And this is pretty normal, right? Unfortunately, this was not sufficient for our project. So just to get everything to build at all required all kinds of drivers and patches and crazy stuff for all this legacy technology. It all had to be installed on the build machine or nothing would work. So we painstakingly reverse engineered all this stuff and automated the process so that it could be done on any machine. You could just install and get this automated build to run. And we used an artifact repository called Artifactory to store all these components, and that's how we automated everything. So that's how we got it to all work. Notice we could still have all the different branches and everything. So a little bit more complicated, but we got it done. So let's take a look at how it changed things to get build automation going. And here we are. So now we can see our build process has been streamlined just like that. The build ready step is gone. That's cool. That's cool. So one step is just completely eliminated, automated away. And you can see the Kanban visualization makes that absolutely obvious. That column is just gone. And now builds just happen automatically. As soon as code is checked in, the build gets kicked off. Bob's your uncle. However, we still have some quality problems. So it is time for step 2. Okay, what is step 2? Test automation, naturally. So now in a normal software application, the business logic is here in the middle tier, right? In between the user interface at the top, the presentation logic, and the database at the bottom, okay? And that's great because that means that you can focus on your testing just in the middle part and do most of your unit tests, your automated tests for this middle part, right? Those tests are awesome. Minimal setup, they run super fast. This is great. Like, this is the normal way you do stuff, right? No problem. So where's the problem? Well, unfortunately, that did not work for us. In our legacy system, the business logic was all contained in the database stored procedures. Can you believe it? But that used to be the state of the art. We're talking many, many years ago. It had never been rebuilt, even though we've added a bunch of new technology on top. Still, most of the data of the business logic was in these stored procedures. And the user interface had the rest of the business logic, lots of business rules and things like that, all way up in the business logic. So basically, all the places it shouldn't be, and none of the places it should be. So what does that mean? Well, that means that anytime you want to test anything, you got to go through everything. You got to go through all three layers. So essentially, you really don't have much in the way of unit testing. What you really have is everything ends up being kind of a full integration test, end-to-end test. And that means lots of setup. Every test requires a full database, and the tests are going to run a lot slower. And you have to reset everything between every single test. Yikes. So lots of work, not much fun, but something is better than nothing, and we did it. We wrote these tests. We had to get started somewhere. We couldn't just wait and say, oh, we're going to rewrite all these 2 million lines of code. No, it's not going to happen overnight. So we started writing these tests. We did it. And here is what it looked like. So you can see that we've got our automated build. Now we've enhanced that with the database-based tests. See that in the middle there. And you can see that because the tests take a long time to build, we segregated them into suites. So we had multiple test suites, and we ran them all in parallel on different machines. So the build required more and more machines. But the advantage was that the overall build was faster, because each of these tests is pretty intensive. It can take a long time. So by splitting them up and running them in parallel, we still got the fast build times that we needed. So it was basically like split up like a diamond and then come back together at the end. And so that is what we did. So now we have automated builds, and we're starting to have some automated tests. So let's take a look at our new workflow, looking at Kanban, a Kanban visualization, and see where we are. So you can see here the test database image coming through, and that's how the tests are getting run, the brand new image every time. So let's take a look at our workflow, and we can see that quality is starting to improve. This is great. We're seeing fewer problems. That's awesome. We're getting great feedback in our build, but we still don't have a lot of automated tests. We have some, but we don't have a lot. And the problem is it still takes a long time to deploy a system to a test environment for the testers to do their manual test cases, right? So that's still a big problem. So that is what we need to fix next. And how do we do that? Deployment automation. So deployment automation, we need to automate that deployment step and make sure that is not manual. So here is what a typical automation pipeline might look like. So you could use a tool. In this case, we've got TeamCity, the build server, Artifactory, the binary repository. Everything gets built. And then the last step is to deploy things to different environments. We have different environments. We have our system test environment, our acceptance test environment, performance test environment, maybe multiple other test environments to do A, B, different things. And that was certainly the case for us. We had 4, 5, 6 test environments. And we used Octopus Deploy, which is a great tool. It's a vendor tool. And that enabled testers, not the build master, not anyone else, but the testers by themselves, self-service, to log into Octopus Deploy, look at all the available releases, pick a release and say, I want that release and I want you to deploy it here. So they could do all self-service in that way. It was awesome. And so why would you need that? Well, imagine, if you find a bug and you realize that it probably happened earlier, it's probably been there for a while, you might need to install multiple versions until you finally figure out where exactly that bug got introduced. Or maybe we want to compare different versions and really see, where some behavior change. Maybe some users are complaining about some of the new ways that things are working now. These are forensic scientists that are using our software. So there's a very specific type of user that we have, very, very demanding users. So this is sort of the typical test deployment scenario for automation. And did this work for us? Of course not. It cannot be this simple, alas. So what did we really have to do? Well, we could use Octopus Deploy. We got it to work, but we had to write all kinds of scripts. So essentially, we had to write a bunch of scripts to automate the deployment process, starting with the steps pre-deployment, cleaning everything up, getting everything ready, then installing the software itself, then restoring specific test data, and finally making some extra configurations post-deployment. So with all of that scripted, finally, we got everything automated so that with a touch of a button, we could really deploy an instance. So we finally got that done. So what does that look like? If we reanalyze our workflow now with deployment automation, what does that look like? Well, now we can see yet another step has been eliminated. So test setup is just gone. That is now automated. So you can see our full workflow is getting simpler and simpler and simpler as DevOps is automating away things that we used to have to do by hand. So this is great. So the test setup step has been eliminated, and deployment not completely eliminated, but basically at this point it's just press the button. So we still keep that as a step because we want to record exactly when and how deployment happens. So it's a step, but it's a trivial step. Whereas before it was this really lengthy step. So we basically eliminated one and all but eliminated another one. So we're almost there, but we're still getting some false positive defects. So why is that? Why are we still getting some false positive? Meaning things that we think are defects, but then when we dig deeper, we realize it's not really a problem in the software at all. So why are we still getting those? Well, to understand that, we need to take a look at step number 4, which is configuration as code. So what we realized is that our system really has 2 major pieces. The first piece is our actual system. That's the interface, the database, all the stuff that we're building, right? That's the actual system. There's a whole nother thing underneath that, which is our operating platform. And there are a million different things that have to be configured just right for the system to run within that operating platform. So configuration as code is how can we take care of that bottom piece? Everything else that we've been doing so far has only been the top piece, nothing below. So there's this whole other piece that we need to address. So now normally, this kind of thing would be done either through Docker containers or through something like Chef, we're showing here, or Puppet, which would automatically configure all of our servers, right? They would take care of all of this stuff. That's great. So what are all the things that we need to configure? What are all those things? Well, we made a list, and it turns out it was quite a lot. So installing the operating system, getting Active Directory set up, the firewall configurations, third-party drivers, libraries, PKI certificates, tons of stuff, right? So lots of different things. So how was all of this being done historically? Well, the way we've been doing things for 20 years was manually. And so what we had is the customer had been maintaining a 300-page document filled with these full color illustrations and instructions for how to install everything. And this is how it had been done for all these years. So we got to do better. We got to do better. So first of all, let's at least, shave off some of the really sharp edges and create a couple of scripts. So we did that. We created a couple of scripts, and that, we still had a big manual, but it started shrinking, which is great. So now we've got all these scripts, and that's great, but how can we go even beyond that? So to do that, we needed something even better. And so we created what we called the configurator. And the configurator, it took care of it. So how did the configurator work? Well, basically, the configurator is our sort of homegrown version of Puppet or Chef, which automatically created all of our test environments. Now, the thing you have to understand is that these test environments include more than 24 separate nodes, all simulating, different state and local labs, and each one is configured differently. So this is pretty unusual because normally in a normal situation, you just create a bunch of clones, right? That's sort of what you do when you're deploying something, you want to scale it up. You deploy it across a whole bunch of instances, and they're all the same. But here, every single instance, every single node is completely different, configured differently. So it's way more complex. But regardless, by creating this model here and a bunch of rules and a bunch of scripts using PowerShell, we got it done. So great. So now we have full configuration automation. We also ended up plugging that into Octopus Deploy. So Octopus Deploy is sort of doing all this stuff. It's configuring and then deploying, doing everything. So other projects may use something like Ansible for the same thing, right? So that was our Octopus Deploy. It just has that benefit that testers can log in and they can sort of graphically pick where they want to go and what they want to do. So it was a nice tool for us. That was a good option for us. So given this, what does our fully streamlined workflow look like? And here it is. So this is our workflow with build automation, test automation, deployment automation, and configuration as code. Now, as you can see, we have greatly reduced our incidence of false positive defects. And the bottom line is that configuring new environments shrank from weeks to just hours. And if you add that up over months and years, what you're talking about is a huge savings to the program. So this effort basically paid for itself within less than a year. So that is our journey. And so what have we done? We demonstrated how DevOps practices benefited our project. We looked at each one of the different pieces: build automation, test automation, deployment automation, configuration as code, or infrastructure as a service, another way to put it. And even though we started out with legacy technology, we showed that it can be done. And finally, we saw how the systems thinking approach to implementing Kanban was a great guide for us along our journey. And that's my presentation. Thank you very much. And with that, I would love to hear any questions or comments that you might have. Thank you.